Astronomy is a very wide field, from studying the beginning of the universe 13.8 billion light years away to studying solar flares and sunstorms only one astronomical unit away. And in the heart of all the science in astronomy lies different types of telescopes helping astronomers observe different objects. So let's find out where these types are and what makes them unique in the world of astronomical observations. One way to classify telescopes is by their location, on the ground versus in space. So we have ground-based telescopes, those that are stationed and operated from Earth, like the Keck telescope, the Magellan Telescopes, and the Lowell observatory. Ground-based telescopes have to be built at high altitudes, preferably on mountaintops, to provide the perfect environment for observation. Mountaintops provide a couple of benefits for observation. 1. They're away from all the light pollution, unlike cities where light pollution is at its maximum. 2. Mountaintops and high altitudes have less atmosphere, which means clearer sky for observation and less atmospheric distortion. And then we have space-based telescopes, those that are stationed in space and operated from Earth, like the Hubble Space Telescope and the Kepler Space Telescope, and those have the advantage of being above Earth's atmosphere, thus producing better images that are not distorted by the atmosphere. On the other hand, ground-based telescopes produce blur images due to what is called atmospheric distortion, and that to adjust the quality of images and account for atmospheric distortion, ground-based telescopes have to have a set of equipment called adaptive optics. Now you might ask, if space-based telescopes avoid the atmospheric distortion and therefore produce better quality images, then why not use them all the time instead of ground-based ones? Will space-based telescopes make ground-based telescopes obsolete? Well, of course not. And I have a couple of reasons to convince you why astronomers will always need ground-based telescopes. 1. The cost. It took NASA and the European Space Agency ESA $1.5 billion to deploy the Hubble Space Telescope in orbit, and then an extra $50 million to fix a faulty mirror that was discovered only a couple of months after Hubble was launched. So the cost of fabricating and operating telescopes is astronomically higher, pun intended, when they're in space than when they're on the ground. 2. Maintenance flexibility. If we have a faulty mirror or a problem in the electronic circuit of a ground-based telescope, it's somehow easy to solve. Just ship the faulty equipment back to the fabrication factory to have it fixed. But in space, things aren't quite as flexible. If something goes wrong with a space-based telescope like the Hubble Space Telescope, for example, we have to send astronauts to fix the problem, which is both risky for the astronauts and costly for the space agency. Furthermore, other space-based telescopes don't even have the luxury of being fixed once a problem arises, and that's due to their higher orbit around the Earth, which makes it impossible for crewed missions to reach them. 3. Reliability. Space-based telescopes are constantly in danger of being bombarded by space junk or tiny space debris, which puts more effort on engineers to design protective layers for the telescope and its mirrors, which again costs more money. However, ground-based telescopes are more reliable and far away from any space hazards, protected under their dome from any dust particles or storms in Earth's atmosphere. 4. Competence. Astronomers around the world write proposals to obtain observation time on telescopes all around the world. And when it comes to proposal acceptance for time on space-based telescopes, the competition is sure higher. The Hubble Space Telescope, for example, has an acceptance rate of 0.2. Yes, you heard right. Only 2 proposals of each 10 submitted are approved. Another way to classify telescopes is by looking at the optical range they detect, which basically means the kind of light the telescope is able to see. Not all telescopes can see all kinds of light. Just like humans only see one kind of light, that is, the visible light, telescopes can also see 1 or 2 kinds of light. The light spectrum is huge. It has so many ranges extending from gamma rays to visible light to radio waves, and a bunch of other ranges in between. Fortunately, astronomers have different telescopes seeing different ranges to help them do different kinds of science. And before you get all jumpy asking why we need to see in all the ranges, I have just the answer for you. See, light is information, and even though it may seem as if visible light has all the information we need to identify an object, other ranges of light also contain vital information and equally as important to study that object. For example, infrared light gives us information about the temperature of the object, which is otherwise impossible to obtain from visible light, and gamma rays give us information about how energetic the object is. Radio waves, on the other hand, gives us information on things like the cosmic microwave background radiation, which is the radiation left over from the Big Bang that was first detected and mapped using radio wave astronomy. So let's take a look at different telescopes observing in different ranges. And let's start with everyone's all-time favorite telescope, the Hubble Space Telescope. The Hubble Space Telescope is special because it observes in a wide optical range from the ultraviolet to the infrared, which means it helps astronomers study the same object in more than one range of light, which provides deeper insights into the comprehension of the object. For example, in the year 1995, Hubble took this picture of the Eagle Nebula, publicly known as the Pillars of Creation, that is 7,000 light-years away. The picture was taken in visible light, viewing gas and dust and the fine outlines of the nebula itself, in addition to its chemical composition. Then later in 2020, scientists wanted to revisit the Pillars of Creation again, but now using a different optical range. So they pointed Hubble to the Eagle Nebula and took this picture in infrared light, showing more extraordinary details that weren't before visible, such as the enormous number of stars that are now obvious in the background. Some of the biggest discoveries Hubble gave us was to help astronomers in precisely calculate the Hubble constant, which determines the rate of the universe's expansion, as well as keeping track of the growth of many galaxies across time. Hubble also had a legacy in helping scientists to measure for the first time the atmospheric composition of an exoplanet. Some other telescopes are not as lucky as Hubble and can only observe in one optical range, just like the Spitzer space telescope that sees light in the infrared range only. NASA deployed the Spitzer space telescope in the year 2003, and it was expected to only last for 5 years. But it surprised everyone with more than 16 years in operation, to be shut down only in January of this year. Studying the universe in infrared light is so important because we can see exclusive footage of things like stars in the beginning of their formation period, the location of dust and baby stars in galaxies, material falling into supermassive black holes, among many other events and objects. Since Earth's atmosphere filters infrared light, astronomers had to have a space-based telescope in order to do infrared astronomy, and that's where the Spitzer Space Telescope comes in. One of the biggest discoveries of the Spitzer Space Telescope was the observation of 7 Earth-like planets around a single star back in 2018, a discovery that took Spitzer and astronomers more than 500 hours of observation. Another big hit by Spitzer is providing astronomers with more than 2 million images to compile an extensive map of our Milky Way galaxy back in the year 2013. The images provided by Spitzer were taken over the course of more than 10 years, and the map helped scientists to detect an extra amount of carbon in the galaxy than predicted, and it continues to drive new science today. Now let's take a look at another type of telescope that observe only the X-ray range of light. And as an example, we're going to discuss the Chandra X-ray Observatory. That's a space-based telescope launched by NASA into space back in the year 1999 and expected to last only 5 years. But surprisingly, Chandra is still alive and giving till today. Observing light in the X-ray region is important because it helps astronomers study high-energy events like matter falling so close into the event horizon of black holes, X-ray pulsars around neutron stars, and extremely hot gas clouds that go up to hundreds of millions of degrees, which otherwise will not be visible. The Chandra X-ray Observatory made lots of great discoveries together with another X-ray observatory called the XMM Newton, developed by the European Space Agency ESA. Data collected from both helped astronomers measure the spin of dozens of black holes, by observing how far the cloud of gas around each black hole is. And both Chandra and XMM Newton helped astronomers understand the nature of X-ray background radiation when they both produced an image of the sky's background X-ray radiation back in 2016. Chandra and XMM Newton also have a hit in the field of exoplanets. They both collected data that led to better understanding of star-planet interactions, like the data from the system HD 17156, when the observatories noticed a flare from the star whenever its hot Jupiter planet passed by. Furthermore, Chandra is constantly monitoring the supermassive black hole in the center of our Milky Way galaxy. Now, since we talked about different types of telescopes, let's run quickly on some of the most awaited telescopes coming in the future. The Lynx X-ray Observatory is a NASA space-based telescope still in the making. It will observe the sky in X-ray and will be the successor of the Chandra X-ray Observatory. The Lynx Observatory will be 100 times more powerful than the Chandra Observatory, which will allow it to observe objects more than 10 times further away. The Lynx Observatory is supposed to help astronomers better understand the nature of the earliest black holes formed in the universe and the evolution of galaxies, as well as the births and deaths of stars. And of course, we can't talk about future telescopes without mentioning the James Webb Space Telescope, a telescope made in collaboration between NASA, ESA, and the Canadian Space Agency. The James Webb Space Telescope will observe light in the infrared region and is supposed to be the successor of the Hubble Space Telescope. You might have heard all the fuzz around the James Webb Space Telescope and how its deployment keeps getting delayed and the frustration of astronomers. Despite how you might think that NASA is a big fan of delaying missions, it's not without its reasons. Missions typically get delayed because of bad weather on launch day or extra checkups that have to be done. In the case of the James Webb Space Telescope, every single detail has to be checked and rechecked. There's no room for error, and that's because there's no chance for future checkups or servicing missions like in the case of the Hubble Space Telescope. And that's because the James Webb Space Telescope will not be placed in a low Earth orbit around the Earth like Hubble. Rather, it will be placed in what is called a Lagrange point, which is a point 1.5 million kilometers away from Earth, away from the reach of any current or future crewed missions to perform modifications or checkups. We don't yet know when exactly the James Webb Space Telescope will be launched, but it's scheduled for some time in 2021. And before I let you go, I want to let you know how grateful I am for keeping up with me through the show. I'd love to know if you think I did a great job, so why don't you show exactly that by pressing that like button? Or if you think we must stop making content like this, and you want something more of your taste, leave a dislike. And please let us know in the comments what kinds of content you're interested to see. A new video comes up every day that's sure to pique your interest. So if you want to see those, click on that subscribe button. And don't forget to press the bell-shaped one too, so we can send you a notification whenever something new comes up. See you in the next one, fellas. Stay insanely curious.